so much for joining us again this afternoon. My name is Lindsay Marshall. I'm the room host for today, and I'm delighted to introduce Sam Coyne and Sean McLaughlin and their presentation today is going to be around your continuous analytics for predicting and improving the performance of industrial process control. And the guys are from Georgia-Pacific. So if we could give them a warm welcome, and let's hand over. Thanks, Sean. Thanks, Sam.
Thank you.
All right, we are back. If you've seen our other sessions last year, you probably heard us talk about ESP and some other things. So we've got a different topic this year. Promise it won't be duplicative, but we'll start with a round of intros. I'll give you a little bit of background about Georgia-Pacific. I think you probably heard some this morning on the main stage, but we'll give you a little bit more. Then we're going to go into a project that combines some stuff I really like. And time series, we're going to talk about forecasting. We're talking about forecasting in an industrial situation. So what I want to do, and what I hope you guys come away from in this session, is that I will stop and pause and say, hey, I think this is a good nugget. It's really no good if you come to these sessions and you just kind of space out for 45 minutes and you could be doing other things. And I'm hoping that you at least have a bullet point list of, okay, that may be a good topic, let me experiment with that thing. So that's what we want to do throughout this next 45-minute session. So, like I said, we're going to get into some intros. My name is Sam. I've been with Georgia-Pacific for almost 12 years, rounding a little bit. But in that time, I've been part of a lot of different groups that do analytics, data science, of course, AI. At some point, they changed my title from analyst to data scientist, but Sean and I work on a rather large data science team. We are part of a group called the Collaboration and Support Center. And we do tons and tons of time series data, IoT, telemetry data, and it is on us to make sense of all that and give good predictions. So I'm going to let Sean introduce himself, and then we're going to talk about GP as a whole.
Hey everyone, Sean McLaughlin. I've been at Georgia-Pacific, similar to Sam, but rounding about 5 years. Work at the CSC with Sam, Collaborative Support Center, and work mostly on operations projects, so making sure our mills are running continuously, creating quality products, and I've been using SAS for around 10 years now in different varying degrees.
Thanks, Sean. Okay, so the first thing I want to start out with is kind of this misconception that I've heard in different kind of data science teams really ever since around 2014. I'm assuming it still exists somewhere out there, and that forecasting and telemetry or IoT data don't mix. You know, whenever you think about time series as a whole, you have really inference and you have extrapolation. And of course, if you've seen any of our presentations before, you know that we do a lot of time series modeling for inference. Tell me what's happening now. Extrapolation, of course. Forecasting, tell me what's going to happen. And as I mentioned, I've heard over the years, you know, that is for that kind of extrapolation. Use it for demand planning, use it for inventory planning, use it for supply chain, but it doesn't really fit in with operations. And hopefully this presentation will kind of challenge that a bit because it certainly is very much a technology that we want to use. So want to put that as a backdrop and say that, you know, on this talk, we're going to be going into a situation where we have two components and we have many different users of this thing that we're going to talk about. The situation we're going to be talking about is forecasting various quality tests. Now, unfortunately, we can't get into a whole lot of the details around that process, but in general terms, we'll talk as briefly as we can about the process that we're going to be forecasting. And also, no forecasting project is complete without multiple users, different audiences who want different interpretation of those results. So we've got all that good stuff coming up. So the session description, I think as you read through this, you'd think, well, that's pretty common. That's what you'd expect in manufacturing and data science. Those are the things that you're like, yeah, even if you were working on, say, anomaly detection or predictive maintenance, you would say, oh, yeah, all those things are true. We need to combine domain knowledge with data science. That's a no-brainer. Neither Sean nor I could probably explain to you paper making without drawing stick figures and Googling a lot. But we could eventually get there. So this solution is, Sean and I are up on stage, but by no means are we the subject matter experts. And, data science is kind of a team sport. We have to learn enough to be dangerous, but we don't have to be the expert. So what are we trying to solve here? We have, in this case anyway, we're going to be forecasting quality and quantity. What Sean's going to talk some about when we get to the actual modeling piece. And those forecasts that we're using are going to influence someone's actions. So it's great to have a forecast, but what happens after the forecast? So you give me something, a projection that will happen over some number of hours. Well, okay, cool, but if I'm an operator or I'm anyone in any situation who's consuming a forecast, what do I do with it? I think most industries are feeling this where you don't have the 30 or 35 year experienced person who can just tell you, oh yeah, do this, do that. You have to infer much more with data, and that's hopefully one of the gaps that we're trying to bridge in this whole process. So, a little bit of repetition here, but to really hit all three of these things, we want to consider operating conditions, operator experience, how someone's going to use it, as well as the measured outcomes. How does this thing even perform? We have to work together with mill people. So maybe a long-winded way of saying it, but data scientists, and this is kind of a philosophical point to this whole point, is you should never go off as a data scientist and build something without bringing in your customer basically side by side with you. Those are the folks in this case, and in just about any other forecasting project that I've been a part of, will help you with things that are, that we all call feature engineering. What are the leading indicators? How can I manipulate these certain features that will then be highly predictive of this thing that's coming down the road? So the solution description, and then I promise it won't be as boring after this, but the overall, kind of 5 steps here. I think this is one of the things to write down. This was kind of a revelation for me. I have made so many presentations about ESP, probably since about 2019 on, and that's SAS event stream processing. Don't have time to necessarily cover it today, but there's a lot of great YouTube videos out there. Great resource, great for deploying models. It helped us go from being able to deploy a model in, say, 4 weeks. It took us down to 2 originally. So definitely an ROI on using event stream processing for model scoring. And it also helps in model ops, especially with telemetry data. It natively connects to our historians, our other time series databases like Quasar, and any other data source that we have a need that's going to have streaming data. So that first bullet point, the real-time raw data acquisition, is actually being done with ESP. And I had never thought about using event stream processing to do anything other than score in this thing called MLOps. So you're thinking about it like, okay, that's kind of our time series aggregator in a way, because data in itself from a historian is transactional. It really doesn't fit the bill for time series, which has to be equally spaced. So there's some manipulation that's required, some very common tasks. You have to transpose the data. You have to create new features. You have to do imputation. You have to study and see, is it missing at random? Is it missing not at random? Is there something else we need to account for? So a lot of that workload can be accomplished within ESP. And we've done it many different ways over the years. I'm a big Python fan, R and SAS, and I think we've kind of made it work each different way. But I think ESP, first thing that really kicks off this whole thing, is a great way to build a data set. So these next 2, continuous data models and forecasting. By data models, I don't mean a predictive model. I do mean okay, so you've got raw data coming in. What do we lag? How much do we lag it by? What are lagging indicators? That's kind of what we're saying is the data model. It's kind of your template for where you're going to go on this analysis. And finally, point 3, forecasting, topic very near and dear to me. In this case, it's going to be mostly SAS. I happen to be a big time series, let's say, fanboy. I do post a lot about SK Forecast or Prophet, some of those great libraries out there, TS Model with SAS. I love them all equally. They're a lot of fun. So we're going to talk about using that again on these applications, and then we'll show some dashboards, and then what that would look like for an operator versus the other view, which is your engineering or corporate view. As I mentioned, no time series project is complete without having different audience members who want different things. The last piece there, not the last two pieces, recommendation and dashboarding. Interesting here that we have the what do I do part after the forecast, which honestly I had never thought about it. As a data scientist, the forecast is great. I feel like I've done my homework. I did all the steps. Here you go. But this really takes it a step further. Dashboarding. Visual analytics, something that we've kind of dabbled in over the years. I think SAS Viya is kind of like a mansion, and we tend to live in the analytics for IoT rooms of that mansion. And sometimes we see things in visual analytics that we're like, wow, we didn't know that room or that capability even existed. So this is operations. It does run, it's running right now, runs 24/7, 365 to look ahead and hopefully provide a good roadmap for not only operators, but as well as corporate engineering. So whenever your colleagues ask who didn't attend this meeting, what did we talk about? You can say liquor. And we did a deep dive into it. So this is the liquor cycle. Unfortunately, it is just about paper making. It is the not so exciting variety. But this is a diagram that you can find in just about any textbook. This happens to be the one I save on my desktop when someone asks me a question. This is hand-drawn, of course, but we're going to be focusing on the recost cycle. That's going to be in the top quadrant there. So this is probably the least meaningful slide for a crowd of data scientists, just keeping you aware of, okay, where in this whole paper making cycle are we doing our forecast? Same thing again, but now just kind of focus on the lime kiln and the causticizing plant. That's where we're trying to look ahead for some different quality tests and some different quantities to make sure that we can run reliably. So everything, and I'll say really it's any manufacturing process, any upstream process is going to have downstream effects. That's kind of a no-brainer. But especially in this case, and Sean and I were actually discussing today that, how do you quantify the value of a forecast? And I think, one of the easiest ways to do that is, your forecast that you make for X number of hours in the future, you can easily show what you would have done versus what you did do with that knowledge. And and the name of the game for this whole use case is decreasing variation in those quality tests. We want to make sure that what we produce and what we send to the next part of this whole kind of process is going to allow maximum throughput in the next step. So there's probably a lot of data points you could pull when trying to quantify the value and express, well, why do I even need this? I could just do a moving average. A lot of opportunity here to say, well, actually, you kind of get this advantage when you use a forecast. Okay, so the goals. What are we trying to accomplish? And some of this I've kind of already hit on, such as cleaning data, looking for gaps. That's where we were talking about using ESP, looking for data that's missing at random, missing not at random. Do a missing values kind of analysis to understand what are we trying to forecast? How does it look? And it's not written here, but I think the first step of every forecasting project is just plot it. You can do plot or proc eyeball, if you will, for the SAS coders. Look at it. You can do statistical tests for white noise. It's no good if your time series is white noise. there's no point in really taking on the project on to step 2. So all that stuff still live in the is one of our main goals in this entire process. We want to focus on the key measures of quantity and quality, I should say. So we've got some different views there, 2 different types of models. We want to project into the future, a little bit on the forecast horizon. It is hours, not days into the future. So the further you get from your forecast origin, I don't think it's much of a mystery, but your MAPE or whatever your error metric is going to increase throughout time. And then these last 2 pieces, tracking, that's the value piece. I think every data science project needs that. It can't necessarily just be a cool experiment. You have to show some kind of results. And finally, the recommender piece. So I am going to pause for a second here and pass it off to Sean, who's going to walk you through. So, Sam's been rambling on about this stuff. What does it actually look like in a kind of a swim lane view? He's got some data acquisition piece in there. We did have to blur out some of these images, so you don't have to squint. They are blurry. He's hopefully going to focus in on some of the ESP stuff we kind of hit on. But Sean's going to have his points, the bullet points I think are going to be useful. I'm going to pass it off to Sean and let him take it away.
Awesome. Thanks, Sam. Yeah, so I guess we'll start on the left here. So when we were designing this solution, one of the main things was we wanted to be scalable to different mills. And the different mills actually have a lot of different processes. They could be set up differently. And so it makes it difficult to make a product that can scale to these different mills. And at the mills is where the data initially starts. So you have essentially a bunch of different sensors at these mills measuring things like temperature, speeds, and all sorts of different sensors. And you also have knobs, and these are what the operators at a mill will change to try to maintain quality and to maintain the optimal quantity of different liquor bins and vats throughout the mill. And so from there, these different sensors, they're all sending data to Pi, which is a transactional database. So as you know, with time series, you typically want equally spaced data, no missing data. And that's kind of where ESP originally comes in, is the Pi system database is all transactional. So some could be every minute, it could be random. The knobs especially are usually done by hand, so it depends on when they finish the test and when they enter it into the database. So the third box there, ESP, connects to Pi and is able to bridge those gaps in the data. It's able to combine everything from all these different sensors that are all tied to different areas in the process. We use Pi to put the data, or we use ESP to put the data into 10-minute intervals. Although we're doing hourly forecasts right now, that gives us the ability to adjust later down the line. Maybe another facility would want more frequent forecasts and things along those lines. After that, we use CAS as kind of like our permanent data store. So ESP writes that data to CAS every 10 minutes, and from there, our next processes can pick that up. The fifth box, CAS data analysis, that's kind of 2 different things. So that's our forecast and that's our recommender. They both run in 2 different jobs in SAS Execution Studio. And both those are kind of work in tandem and end up going to the dashboard for the operators, engineers, and ourselves to review. Similarly to ESP, that also writes all the model results to CAS. And that's kind of the back end behind visual analytics and everything as well. It's constantly running, constantly in memory, so it makes the front end pretty quick, and it makes it to where anyone at these different mills is able to access the dashboards and everything. So we actually use a dashboard hub, is what we call it. It's also a job and job execution studio, but essentially it adds some layering on top of the VA dashboards, which are embedded in the HTML there for different users to access different links, whether it's a engineer, operator, or a data scientist. And then to go a little bit in more detail on some of the main areas there. So the data acquisition, as mentioned, this is what's in ESP. It's all appending the data to CAS, as mentioned. We are calculating some features there, and in the future, it does give the ability to do some time alignment. So as Sam was showing the liquor cycle, that's over multiple hours. So something that is happening earlier in the process may take hours to propagate down to where we're actually our responses, our quality and our quantity measurements. And we also use it to derive some variables that are time dependent. So just a couple different tags, which is what it's called in Pi, but a couple different variables essentially over time. It's able to combine them and create new calculated fields that we then use in the forecast and in the recommender. And we do have history in there back to 2019 in the CAS table for us to use. So then the forecasting piece. So the way we built this is it's actually pretty easy to add new models. Right now, or at least when we made these slides, we currently had 5 models. Most of them are different quantity measures, and a couple of them are, most of them are quality measures, but a couple are quantity. As mentioned, this is running in VIA. I know it's hard to see, but there is some of the dashboard there, the VA dashboard being shown. Essentially in the top left, you're able to select the different quality or quantity measure that you want to see. To the right, the little yellow circles show you what's going on right now, what's the current value, and what is the value that you forecast is going to be X hours into the future. We usually go, it depends, but usually around like 12 hours, half a day is what we try to get into the future. And down there at the bottom, you'll kind of see the actual plot of the forecast. So on the left is the historical data. The green lines are essentially bounds. This one is for quality, so they want to keep the quality within those bounds. Something else to mention is model evaluation. So when you're talking to an operator at the mill, they don't really know what RMSA or any of those air terms are. So we actually kind of look at that in more of a directional. So did we forecast we were going to be inbounds? Did we forecast we were going to be above, below? And that's kind of how we review results with the operators and the engineers as well. And there are some other dashboards. I guess we probably won't get into the details later, but there are some for the data scientists ourselves to evaluate model performance over time. So essentially like a back test, we're able to go back, view a similar dashboard to this, but with the actual values filled in. And then we have another one that shows the forecast over time overlaid on top of each other. It gets a little complicated because we do run these every hour and you're doing the 12-hour forecasts. So essentially in the future, you'll have a 12 forecasts for each hour in the future. So there are some little creative things we had to do to make sure that it's easy to kind of understand the model performance over time. So the next piece, the recommendation. So we have the forecasts. You forecast you're going to go above bounds, below bounds, outside of bounds. What do you do about that? And this is where we're using a couple different methods. Essentially, high level, we're going back in time and looking what the operators did in the past to fix the issue. And here, this one's blurred out as well on the right, but essentially at the top, again, you can select your quality or quantity measure that you want to view. Below that are your recommendations over time, so adjust these knobs over the next X hours by this amount in order to try to achieve the goals that you want to do. It's hard to see as well in the plot below, but you actually have your forecast, and then there's a little purple dot, and that's where you should expect to be if you do follow the recommendations. All right, so some model assessment here. A lot of this is grayed out, but it kind of gets to the main point. So we tested a bunch of different models from LSTM, RNNs, ARIMA, SARIMA, all those different versions of ARIMA, as well as some more traditional machine learning approaches like just random forest decision trees and such. And we got to the point where we need to decide what model do we actually want to use. So the plot on the left is showing 3 different models. This is, as mentioned, it's kind of hard to evaluate some of these forecast models, but this is just one point in time. We look at a lot of different things. Like I mentioned, the directional accuracy is what we call it. And we also evaluate at each point in time. So as you know, 1 hour in the future forecast is going to be a lot better than 12 hours in the future. So we really want to make sure that we get a good balance of where we're able to forecast 12 hours in the future, but still get accurate forecast 1 hour in the future as well. And the plot on the left or on the right is showing the distribution of those errors for the different models. So there's always trade-offs between them. You can see the one that has the lowest is the ATSM, which is an ARIMA model, although it tails off to the left side a little bit more than the other models. So there's always a balance between selecting the best model. And the way we design this also gives us the ability to, depending on your response, use the best model for that response in that case. I guess, Sam, was there anything else you wanted to add on?
Sure. So as I mentioned in the very beginning of this, there are points where I want to pause and say, you know, if you want to walk away from this session with a few bullet points, I think it goes without saying on this particular slide, and I'll say any time series or forecasting project, it is rarely one model that will just, you know, blow all the others out of the water. So in this case, you can see that, you know, this one's not as blurry as the others, but you can see that there is a deep learning model in there that does not beat the classical methods. So it's always great to start with your linear models, your linear approaches, and then add complexity as time goes on. But really, I think what, you know, Sean is also saying is, hey, don't just stop with, you know, with taking every single known time series approach to man. You should be also considering things like overrides, doing ensembles, getting your subject matter expert involved, like we mentioned in the beginning of this. So all that really kind of goes into evaluating your forecast and understanding, okay, how will this thing help me in the end? And that it's rarely not just one model.
These are as well. We review these with the engineers. We try to leave a lot of the operators out of reviewing models, but we do review all the model comparisons and everything with our engineers, which they kind of bridge the gap between us and the operators, but they're able to help us say, hey, you need to simplify this model some, and we've actually found by simplifying the models you can get better forecasts further out, especially with something like ARIMA where you have to forecast all your predictors as well, which is just compounding different errors from those forecasts over time. So these are definitely something that is really useful to have as we have talks with our engineers and make sure that we're meeting the needs of the operators at the facility. All right, so now to get into some of these dashboards. So high level, top one is for operators, middle one is for engineers, and the last one is for data scientists. So the top one is what you saw a little bit earlier. It's just, it updates every hour. There's no history to go back in time, but it's what they would have kind of as their live view as they're running their different area of the mill to see, hey, are we going to run into issues with the quantity of the liquor we have? Are we going to leave the bounds of quality that we need to be in to make the quality product that we need? There's 36 hours of history on the left with our 12-hour forecasts, and we also do have color coding to kind of indicate where they're at in the process. So this one doesn't have the yellow circles at the top, they're grayed out, but there is some color coding there that red is bad, green good, yellow okay, kind of like a street light. And we also do have the ability, so the operators at the mill aren't the most technical savvy, and there could be a lot of different people using them. So we did give the ability to have guest access. So they're always able to have that dashboard up, and if it goes down, they have no issue with accounts or anything trying to load it back up. The history view, the data scientists do use this as well, but the engineers will come and look at this a lot. And it's basically the same view as the first one, but you can go back in time. So on the right with your forecast, you'll actually have the actual values there as well to compare against. So maybe you had a problem in the past where quality went outside of the bounds, and you can go back in time and see, hey, did we forecast this before it happened? And if not, we can drill down and figure out exactly what happened. This also does have buttons for us on the right, little links that you can open up, or the engineers to see what key predictors were in the model at that time and how important were they. So you can kind of get an idea of the cause of the bad forecast, or even why things went out of bounds, even if we were forecasting it at that time. And then the last view is mainly for us. It's going back in time. So on this one, it might look like those yellow lines are blurred a little bit, but there's actually 12 yellow lines going around the main point. And that is just because, as mentioned before, you have 12-hour forecasts going out. So for each hour, you really have 12 forecasts for that hour as you get closer and closer to that time point. We also have at the bottom a table, so you can go back and review the actual data values, just because sometimes the graph can get a little bit complicated there. Another option that we have, if you want to kind of generalize things a little bit more, is there's a button that just averages all those forecasts together. So you really just have one yellow, one blue line to kind of evaluate over time. And yeah, so I guess, Sam, was there anything on
Sure.
that you wanted to add as well?
So a frequent joke I make at these conferences, I'll stick around and teach PowerPoint art lessons at the end of this. So those are the necessity here. But I think one thing that Sean made a point on that probably is another thing that you may want to take notes on, or at least I think this one's worth stopping and pausing and thinking about is, you're going to have different different consumers of forecasts, and they're going to care about different things. We've talked about that earlier on. And really, you can't necessarily make everybody happy all the time, or however that expression goes. But there are things you can do that you can focus to cater to your audience and things they care about. Particularly, Sean just walked you through the three, but probably the biggest one on the third, the data science view, is why should I even trust your forecast? What did you do? How did you forecast, this random Tuesday last August? There's the ability to drill in, go into things and understand, did we get it right? Did we get it wrong? And that helps build trust. That is kind of, if you've ever worked with some of the legacy SaaS products, the rolling simulation on some of the other forecasting tools, that is similar to, not exactly, but it is a similar concept. So I guess to wrap it all up, I think we've hit a few points. Number one, the first thing that we hit on was forecasting. It's not just for demand planning. It's not just for supply chain. It is for really time series of any shape or size, including industrial processes. We talked some about the different options out there. We've done a lot with SaaS today, but as I mentioned, I also big fan of SK Forecast, the Profit Library, Facebook Labs, as well as the Auto Arima. So all of those things are great, but make sure that you're evaluating different course methods when you're building these models. The other point, one of the points I made early on, was about ESP, Event Stream Processing. You may have heard our presentations before about event stream processing being an engine that can be used to score models, which is absolutely true. However, in this case, we found a new use for ESP, which is data prep. And we talked about some of the challenges that you're going to have with telemetry data. You're going to have missing values. You're going to have to interpolate. You're going to have to transpose. You're going to have to do engineered features. So event stream processing, to me, having written both Python and SAS code in my life, I think has kind of sped us up. So that's another great use case of event stream processing. We talked also, we just hit on different views, how you present your forecast, how people are going to actually use your forecast. I don't think we need to spend any more time on that. But we also mentioned about how to quantify the value of these things. Forecasting is a little bit tough sometimes, and you have to kind of ask yourself, of simulation. If I had been in, time in the past and I've had access to this information, what would I have done differently? Would I have done anything differently? And then observe kind of, okay, if Sean is kind of at the controls and he has access to a forecast and he acts on that and it does something, it goes in the direction he thought it would, that's great. If we somehow missed it and Sean still knew the action, then we obviously as data scientists have work to do. I guess some of the other things just that we've learned throughout this process is, don't be, afraid to admit when you don't know something about a process. Probably the second slide we talked about was about subject matter expertise, and we as data scientists, for the most part, don't have it, and we have to sit with our partners to get it. And we kind of, as I mentioned, they are the most valuable resource you can have as far as deploying your model, doing the things that we don't necessarily love doing in data science, data prep, feature engineering, leading indicators, lagging indicators, things that we typically rely on cross-correlation plots to tell us, when we could actually just sit and talk with somebody and get this exact same information and make us all more efficient. So those are some of the main topics here. Hope you enjoyed it. You can tell, I think both of us are very passionate about time series in all its many flavors, extrapolation, inference, many use cases in all of IoT. And really, it's all time series data to us anyway. So we are really rounding down to the end here with about 7 or 8 minutes left. We've gone over just a little bit. We thought we'd have 15, but we do have some time for some Q&A and happy to chat about anything related to forecasting.
I think I heard you say that you're using ESP to append tables and CAS. Is that correct? And if so, how are you doing that, if you can elaborate?
Sure, do you want to take that one?
Yeah, so there actually is it's built into ESP, and there's a connector at the end, a CAS connector, that gives you the ability to append to those tables.
Can I ask a follow-on?
Sure.
Yep.
Are you operating your VIA deployment in the cloud? And if so, how does ESP handle periods of time where you lose connectivity to your deployment?
So we are in the cloud, and we really haven't had any issues with losing overall connectivity, but we do have issues with just sometimes data stopping, or they're doing updates to SAS and we have to bring down ESP. And it's something that we have some fail-safes built in to where it will, maybe if VIA goes down, the CAS table gets unloaded. We have some fail-safes to reload that CAS table and as well pick up on missing data that we missed if ESP went down as well.
Edge deployments are also something that I think we've been kicking around for a while now. I wouldn't say we're experts, but that is, of course, the alternative.
I think there's
There's a question in the back.
Go Lions, by the way.
How do you handle the missing data? Do you have a predefined process for your company, or do you have to have the human to look at the missing data case by case?
I don't think it's necessarily, maybe it started out that way with kind of the early phases of the project and understanding, as I mentioned, is it missing at random? Is it missing not at random, and doing that kind of exploratory data analysis? Absolutely, in the beginning, it's, okay, Sean, let's sit down and let's plot this thing and see why is we missing values. Basic questions too, like, is it only 10% missing values? Is it 50% missing values? If so, we need to stop and say, time out, something's up. So one of the ways I think we've kind of across many different projects is if it's not too severe, which is very subjective, right? If my use case, 10% missing could be very severe. Sean's use case, 10% could be no big deal. The easy button and the most trusted, tried and true method is to do a last value carry forward. That is an acceptable solution whenever there's not a persistent underlying problem. If we miss a couple records here or there, fill forward is probably the most dominant strategy. I don't think we've ever been in a place where we've been so starved for data that we had to do something like, say, create an ARMA model to fill in missing values or anything more complicated than what you could do in Pandas or DataStep. So, check out the Pandas documentation for fill in A. There's a couple different methods there, and for the most part, works out really well.
And to add on a little bit to what Sam was saying, so we actually don't fill in the missing values in ESP. Part of that is so when we're doing the modeling, it gives us the ability to test different imputation methods. And another aspect to that, which Sam kind of hinted at, is the missing values might be indicative of a problem getting data or a problem at the facility. So we actually have some data quality checks on that CAS table afterwards, so that if there is missing data coming out of ESP, we can go and drill down into exactly why that is the case. Is there any-
Retraining is happening every day. As new tests come around, we do retrain our models. So it's fairly frequent. I don't think we've ever run across something where we just said we couldn't deploy it. I've only run across that one time working in SAS trying to get moving window PCA to work in ESP, had some trouble with that. But as far as like if we make an ARMA model work, or let's say we're doing an auto ARIMA, sometimes those PDQ parameters are going to alter between different samples. So we've never hit really any errors with that. It's been fairly consistent with the correlation structures. I don't think we've ever run across a time though where we couldn't get an LSTM or recurrent neural net to work. It may take some more finessing to get that to deploy, but we've not really hit a problem or hurdle of not being able to take a time series model and put that into production.
And I think a lot of that is just because we are running it in jobs. If we tried to add these models and put everything fully in ESP, we probably would run into more issues with what's supported in ESP, and even updating those models would be a little bit more difficult because I think you might have to restart the project to get the new A store. But currently we haven't really ran into those issues. Awesome. Any other questions? Perfect. Well, thanks everyone.
Thank you.